Hello everyone, welcome back to my channel Code with Vinay. Today we are going to write a recursive program to generate lucky numbers in Java. I have already covered the iterative approach in my last video. You must watch that video first if you have come to this video directly for better understanding, as this video will build up on the last video instead of starting from the scratch again. Let us begin with a quick recap of what are lucky numbers. Let us say we want to generate lucky numbers for n is equal to 10. We take a list of all natural numbers up to n and remove every second number. From the remaining numbers, we remove every third number. Then we remove every fourth number. The process stops when it's not possible to eliminate any more numbers, and the survivors or the remaining numbers are known as lucky numbers. So in this list of 10 numbers from 1 to 10, if we eliminate every second number, we'll be eliminating 2, 4, 6, 8 and 10. Then we'll take the list of remaining numbers, that is 1, 3, 5, 7, 9. Then we'll eliminate every third number, and here there is only one third number, that is 5. So 5 will be eliminated. Then again we'll take the list of the remaining numbers, that is 1, 3, 7, 9. And we'll try to eliminate every third number. In this case, that number will be 9. And then we'll again make a list of the remaining numbers. And the remaining numbers are now 1, 3, and 7. And when we try to eliminate every fifth number, there is no fifth number. So 1, 3, 7 are the lucky numbers for n is equal to 10. Our previous approach, that is the iterative approach, was to take an array A with the first n natural numbers, move the elements not to be cancelled to another array lucky, then change lucky to array A, and then repeat the process till we reach a scenario where it's not possible to eliminate any more numbers. This is the iterative program that we developed in the last class. I have just renamed the name of the class to recursive lucky numbers from lucky numbers to reflect our objective. The objective is to change the approach from the iterative to recursive. The value of n is fixed to 10. That is, if I run the program, I'll get the lucky numbers for n is equal to 10. That is 1, 3, 7 as we discussed. So here we are getting 1, 3 and 7. Now, this video is not a video on the basics of recursion. I've already made a video covering the basics, and if you feel that you need to brush up your concepts, then you can watch my earlier video on recursion. I have shared the link to that video in the description below. In order to convert this program from iterative to recursive, we'll need to free ourselves from thinking iteratively. That is, instead of taking a loop to iteratively remove numbers, we'll think recursively and we'll create a new method, getLuckyNumbersRecursive, to accept an array along with an offset, that is the position to cancel, perform the cancellation, and then again call the recursive method to perform the cancellation with the increased value of offset. So let's create our recursive method. We'll go down over here and we'll say public static int array, that is the return type is an integer array, and we'll call the function get lucky numbers and we'll add recursive to it. And then we'll pass the array, let's call it A, and the offset, that is offset. Our earlier getLuckyNumber method will act like a helper method. Now we'll move the main logic from the helper method to our recursive method. Now, if you notice, we are passing the offset as an argument, so this will be removed. Then, since this is a recursive logic, we'll get rid of the loop. Then I'll reformat the code. Now, after the copy paste, the array is not declared over here, so we'll say int box bracket to declare the array. And then we'll move up and remove the reference to the earlier array from here. Once that is done, we will remove the line A is equal to lucky, which we were using to designate the array lucky to array A so as to perform elimination again. So let's remove that line because now this has to be done recursively. That is, we'll say Instead of return lucky, we'll say get lucky numbers recursive. We'll call our recursive method. We'll pass our array, which is now lucky, and we'll increase the offset by 1. So first we'll be cancelling every second number, then every third number, and so on. Let us call our recursive method get lucky numbers recursive from our helper method get lucky numbers. And to do that, we'll just go up over here and we'll say return get lucky numbers recursive. We'll pass the array A and we'll pass our first offset, that is 2, because initially we want to cancel every second number, and later on we'll again call the get lucky numbers recursive method by increasing the offset by 1. Now let us discuss one of the most important steps in a recursive approach, and that is the base condition or the exit condition. The base condition will be the case when one cannot cancel any further, meaning that the value of the offset is more than the length of the array. Notice that we are creating a new array lucky on each recursive invocation, and the size of this array lucky is shrinking after each set of elimination. Let us write our base condition. So we'll say that if the offset passed is more than the length of the array, that is a dot length, then we'll say return the current array. With this, our recursive implementation seems to be complete. Let me remove this extra new line from here. And now our program is complete and it's time to verify if it is working or not. Recall that for n is equal to 10, the lucky numbers should be 1, 3, and 7. Let's run the program. So we'll go up, we'll say run Java. And there we are getting the same answer, that is 1, 3, and 7. And that's it. You can now generate lucky numbers in Java using recursion. I hope you found this video helpful. And if you have any questions or comments, please leave them down below. Thanks for watching and I'll see you in the next video. Till then, happy coding. Your feedback is valuable to me. I want to make sure that my videos are clear and helpful. You can follow me on the internet on any one or all of these channels.